Welcome to another episode of Spelling Bee Ninja. If you're eager to dive deep into the fascinating world of science, you're in the right place. Here, we explore essential concepts and celebrate the legacy of incredible scientists. If you love learning about the wonders of chemistry and the people who shaped our understanding, make sure to subscribe. Join our community of curious minds and explore a treasure trove of knowledge. Today, we're diving into the life and achievements of Dmitri Mendeleev, the visionary creator of the periodic table. Born in 1834 in Tobolsk, Siberia, Mendeleev came from a humble background as the youngest of 14 children in a financially struggling family. His father, a teacher, lost his eyesight, which put further strain on the family. However, Mendeleev's determined mother made great sacrifices to ensure her son received an education. She traveled with him from the countryside to Moscow and St. Petersburg, ultimately enrolling him in university. Despite his challenges, Mendeleev excelled in chemistry, earning a position as a professor at the University of St. Petersburg. Interestingly, Mendeleev was known for his striking long beard and intense work ethic, often immersing himself in his research for hours on end. He was a passionate advocate for education, traveling widely to understand industrial and scientific advancements around the world. Mendeleev's early life and struggles shaped his desire to organize the elements in a way that revealed their hidden relationships and predicted the existence of unknown substances. A quote that epitomizes his insightful approach is, "I saw in a dream a table where all elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper." This blend of intuition and hard work laid the foundation for one of the greatest achievements in chemistry. By the 1860s, only 63 elements had been discovered, but scientists struggled to find an organized, systematic method to understand their relationships. Previous attempts to organize elements by atomic weight fell short and often led to confusion. Mendeleev wasn't the first to acknowledge patterns among the elements. Earlier scientists, such as John Newlands, proposed ideas like the law of octaves, suggesting elements repeat every eighth position, akin to musical notes. However, Newland's ideas were often mocked. Mendeleev built upon these earlier observations and created a comprehensive table that not only organized known elements but also left intentional gaps for undiscovered ones. His insight was groundbreaking. He organized elements by increasing atomic weight and by their chemical properties. He noticed that when the elements were arranged this way, their properties exhibited periodic trends. This discovery is known today as the periodic law. Mendeleev designed his table such that elements with similar properties were grouped in the same columns, which we refer to as groups. Remarkably, he didn't just organize the elements, he made predictions about properties of elements that were yet to be discovered. He accurately predicted the existence of EK aluminum, which we now know as gallium, and EK silicon, which later turned out to be germanium. His predictions were so precise that they astounded the scientific community, cementing his reputation as a visionary. Mendeleev's foresight allowed him to leave empty spaces in his table for these future discoveries. In 1871, he predicted that an element would possess specific properties, including an atomic weight of about 68 and a density of around 5.9 grams per cubic centimeter. When gallium was discovered in 1875, it had an atomic weight of 69.7 and a density of 5.9, validating Mendeleev's predictions and showcasing the strength of his periodic table. Mendeleev also foresaw EK silicon, later identified as germanium, and EK boron, identified as scandium, with astonishing accuracy, predicting attributes like density and melting points. The success of these predictions highlighted the power of his table and established Mendeleev as a true scientific genius. Now, let's delve into the structure of the periodic table itself. The periodic table is organized into rows known as periods and columns known as groups. Each period indicates the number of electron shells present in an atom, while groups contain elements with similar chemical properties owing to the same number of valence electrons in their outermost shell. The organization of the periodic table is a remarkable achievement in classification that enables chemists to predict behaviors of various elements based on their positioning within the table. Understanding the groups is essential. For instance, all elements in Group 1, known as alkali metals, are highly reactive and tend to form compounds with a +1 charge. In contrast, Group 17 elements, called halogens, are reactive nonmetals that typically form compounds with a -1 charge. Mendeleev originally organized his table according to atomic weight, but modern science later revealed that atomic number, referring to the number of protons in an atom, provides a more fundamental ordering system. This crucial shift happened in 1913 when Henry Moseley discovered that the X-ray spectra of elements correlated with their atomic numbers. His work not only refined the periodic table's structure but also led to the prediction of several elements that were yet to be discovered. Tragically, Moseley's life was cut short during World War I, and many believe he would have secured a Nobel Prize had he lived. His contributions built upon Mendeleev's pioneering work, creating a comprehensive periodic table as we know it today. Mendeleev's contributions don't end with chemistry. He was an accomplished economist, geologist, and meteorologist. He wrote extensively about Russia's petroleum industry and even traveled to the United States for hands-on experience in oil production. Notably, Mendeleev established Russia's first oil refinery and advocated for the use of the metric system in scientific and industrial practices. He also researched atmospheric composition and the behaviors of gases, showcasing his multifaceted intellect. Despite his many achievements, Mendeleev faced controversies and rivalries. One of the notable clashes was with fellow chemist Lothar Meyer, who independently developed a similar periodic table and published it in 1870. Yet, Mendeleev is often credited more prominently due to the boldness of his predictions about undiscovered elements. Interestingly, in 1906, Mendeleev was nominated for a Nobel Prize but ultimately lost by just one vote, leaving him widely regarded as a deserving candidate who never received the recognition many believe he warranted. Mendeleev died in 1907, yet his legacy forged his place in history as a great scientist, and the periodic table remains a cornerstone of modern chemistry. The periodic table, as we know it, is not just an arrangement of elements, it's one of science's most iconic and valuable tools. It organizes all known elements and enables scientists to predict the properties of new elements and their compounds. Chemists, physicists, biologists, and engineers alike rely on it to understand the nature of matter. It has been displayed in classrooms for over 150 years and continues to evolve with the discovery of new elements. In fact, to honor Mendeleev's incredible work, element 101 was named Mendeleevium. He once reflected, "I have seen the periodic table in my dreams," illustrating the depth of his insight and intuition. His legacy serves as a powerful reminder that great scientific advancements arise from a blend of hard work, creativity, and vision. The periodic table stands as a tribute to human curiosity, embodying our quest to understand the universe. In conclusion, Dmitri Mendeleev's journey from a challenging childhood to becoming a cornerstone in chemistry is nothing short of inspiring. His organization of the periodic table transformed how we understand elements and their interactions. He didn't just catalog known substances, he predicted the existence of those yet to be discovered, showcasing the power of intuition combined with scientific reasoning. The periodic table remains a vital resource, enabling future generations of scientists to explore and innovate, reminding us that knowledge is a living entity that grows and evolves with discovery. Thank you for joining us in this exploration of Dmitri Mendeleev and his groundbreaking work on the periodic table. Remember, science is not only about facts, it's about curiosity and the relentless pursuit of understanding. We hope you'll continue this journey with us. Until next time, stay curious and keep exploring the fascinating world of science.